Hi viewers, in this video we will discuss about some of the interesting nanostructure exists in nature because one of the interesting area of research in the material science is shifting towards the nanotechnology because nanomaterials exhibit unique properties than their bulk material due to high surface area as well as quantum confinement effect. Nature has evolved numerous nanostructure with optimized functionalities. Studying this nanostructure can lead to biomimetic design and innovation in various fields for the benefit of society. Nanostructures are the material which having the dimension 1 to 100 nanometer. The word nano is came from Greek, which means very small object. Nanoscience is deals about the materials properties at nanoscale, whereas nanotechnology is focused on application of nanomaterials. In this picture, we can see the different kind of object from atomic scale to nanoscale as well as macro scale. It clearly represents how the nanomaterials are very small when compared with other objects. Nanostructured material exhibit unique properties than their bulk material. This is due to high surface area as well as quantum confinement effect. When the particle size reduced, automatically the surface area increased. In the first picture, we can see how the square-shaped particle have high surface area when particle size reduced. In the second picture, we can see the particle size variation with high surface area. Another interesting effect is quantum confinement effect. Quantum confinement effect is a phenomena that occurs when boson of charged particles with restricted within the small volume. It leads to quantization of energy levels with unique electronic properties. This effect became a significant when size of the material became comparable to the wavelength of the charge carriers. As the size of the nanomaterial decreases and approaches the dimension where the quantum confinement is dominant, the electronic and optical properties became size dependent. This means that the properties like band gap energy, absorption, and emission wavelength can be tuned by controlling the size of the nanomaterial. In semiconducting nanomaterial, the energy increases as the particle size decreases. This leads to absorption of the high energy photon and emission of the low energy photons. This property is exploited in the application like quantum dots for displays and light emitting diodes. Now we can see the different kind of nanostructure exists in the nature. Understanding the natural nanostructure is very useful to design the nanomaterials for different applications. Butterfly nanostructure is one of the interesting nanostructure exists in the nature. Butterflies are very beautiful due to their colors. This colors is due to structural coloration rather than the pigment. Butterfly wing have amazing nanostructure and it helps to manipulate the light through the diffraction, interference and scattering phenomena. This nanostructure create new colors by selectively reflecting particular wavelength, leading to intense and bright colors that can change with the angle of observation. Studying this natural nanostructure has inspired innovation in creating colors without pigments in the material science and technology. Here we can see the optical image as well as electronic image of the morpho butterfly. The top image that reflect the optical image of the wing, it consists of large number of scales in the wing. The bottom image, that is FSM image of the scales, clearly shows the butterfly wings are consist of large number of lamellae and ridges on this scale. This amazing structure is very useful for the structural coloration. Previously, we have seen the cross section of ridges. The ridges are like a Christmas tree with alternate layer of lamellae. Here we can see the schematic of light matter interaction in the tree-like structure. So by engineering the nanostructure in the synthetic material, we can produce brilliant and tunable color without using any traditional pigments. This one of the interesting nanostructure exists in the nature. Another interesting effect is a lotus leaf effect. Lotus leaf is a classical example for the hydrophobic surfaces. It possesses remarkable water repellent properties due to its micro as well as nanostructure. The surface of the lotus leaf is covered with tiny wax coated pumps called papillae, which create rough texture at the micro scale. This structure minimizes the contact area between water droplets and the surface, reducing the adhesive force that attract water. On the top of the papillae, the lotus leaf has large number of waxy crystals that form hydrophobic nanostructure. This wax crystal further reduces contact area between water droplets as well as leaf, which enhancing the water repellent effect. The combination of microstructure as well as nanostructure on the lotus leaf surface also impact the self-cleaning property. When water droplet comes into contact with the surface, they tend to roll off, carrying dust water, effectively cleaning the leaf. This lotus effect is widely used for developing self-cleaning surfaces as well as materials which are applied in solar cell fabrication. Previously, we have seen the scanning electron microscope image of the leaf surface, how it exhibit hydrophobic surface. Here we can have the schematic which highlight how the combined micro as well as nanostructure on the leaf create highly hydrophobic surface leading to the cell cleaning effect based on their contact angle. If the contact angle is less than the some critical angle, automatically the surface act as a highly repellent surface. This is will happen in the lotus leaf, which responsible for the hydrophobic nature. Another interesting effect is Chico adhesive effect. We know very well Chico can walk on the walls and ceiling due to millions of the tiny hair-like structure called setae on their feet. The vast number of spatulae on the Chico feet enables them to interact with a large number of molecules on the surface, which creating stronger van der Waals force that allow the Chico feet to adhere the surface very strongly. One of the most remarkable aspect of the Chico adhesive effect is reversibility. When Chico wants to detach its feet from the surface, it can do easily by slightly changing the angle of their feet. This, this reversibility is made possibly by balancing between the adhesive force and the other intramolecular force. This principle is mostly applied to develop reusable residue-free adhesive tapes for clipping the robots, medical devices, consumer products as well as space devices. Another interesting natural complex nanostructure is bone. We know very well bone is a complex composite of hydroxyapatite as well as collagen fibrils. Here we can see how the nanocrystals formed on a collagen fibrils at nanoscale level. When we look at the bone at macro level, it is consist of large number of osteons. These osteons are consist of further lamellar sheet which having the 3 to 7 micrometer. When we further focus on the lamellar sheet, it consists of large number of collagen fibrils which having the 50 nanometer in dimension of the hydroxyapatite crystals. This hydroxyapatite crystal is providing the strength as well as collagen fibrils provide the flexibility. Understanding this complex bone structure is very useful for developing biomaterials for tissue engineering, drug delivery, as well as biomedical devices. Another interesting natural nanostructure is peacock feather. Similar to butterfly effect, peacock feather looks colorful because of tiny structure inside them called photonic nanocrystal. These nanocrystals are arranged in a layer with precise spacing, which creating constructive interference. When light falls on this nanostructure, it gets scattered as well as reflected, and it produces vibrant color vary depending on the observation. Here we can see the scanning electron microscope of the peacock feather and their cross section. It clearly shows their hierarchical structure at nanoscale. The scientists, most of the scientists want to copy this nanostructure to create bright as well as amazing sensor devices as well as screens. So far we have seen the few important nanostructure that exist in the nature, such as butterfly, chickweed, lotus leaf, peacock feather, as well as bone structure. Understanding the nanotechnology as well as nature inspired nanostructure is very useful for designing new kind of solution in various field. For example, in biology various processes occur at a nanoscale level. Understanding the nanoscale effect create a new solution for the new kind of diseases. Also we can create numerous materials with enhanced properties. For example, based on their lotus effect, we can create highly hydrophobic surface. Also we can create highly adhesive material based on their chickweed effect. Also we can create new kind of materials for environment application as well as energy storage. Also we can create new solution for sensor, as well as we can create innovative materials and innovative technology for the developing new materials based on their nanostructure that are exist in the nature. I think this video is very useful to understand the different kind of natural nanostructure, and it is very useful to beginner. Thank you.